Hey guys, welcome to another video, and in this video we'll discuss about response spectrum, design response spectrum and spectral acceleration. In simple terms, response spectrum is a graph plotted between maximum response amplitude versus the time period of linear single degree of freedom systems for a given damping. Okay, you can see the response spectrum of Gorkha earthquake that struck Nepal in 2015. This red one is the vertical component of the acceleration, whereas this blue one is north south component and the black one is the east west component. These both are the horizontal acceleration component. Okay, to draw the response spectrum for an earthquake, first we have to find the seismic acceleration. After that, we can consider a simple single degree of freedom systems like this. Let us consider its time period is 0.1, and if we apply this earthquake to this single degree of freedom system, then we will get a response, right? If we apply the earthquake load in this single degree of freedom system, then we will get an acceleration response. From the graph we can see that this is the maximum acceleration. Let it be a max for this am. Okay, a max. And by increasing the height of single degree of freedom system, we can attain another time period as well. Okay, let us consider another system for time period of 0.3. Okay, and if we apply the same acceleration to this system as well, then we can get another acceleration response like this, and from that we can get another maximum acceleration due to this earthquake. Okay, and if we continue this process for other single degree of freedom systems of greater time period like 0.5 and 0.6 and increasingly any other time period, then we can plot a graph between maximum acceleration versus the time period of single degree of freedom systems. Okay, if we plot that, then we can get a graph which might look like this. Okay, this is the Amax in y direction, and this is the time period of single degree of freedom systems. This Amax is called spectral acceleration. Okay, and we can get this response spectrum curve for this particular earthquake that occur in that region. Okay, to prepare a design response spectrum, we have to consider other many earthquakes as well, and if we draw a response spectrum for those earthquakes that occur in that particular region, then we get response spectrum like this, and another maybe like this. Okay, and if we cover this all graph with a single envelope curve, we can get a curve like this that covers all the maximum spectral acceleration of the earthquakes that has occurred in that particular region. Then this curve that envelopes and includes all the responses of different earthquakes in that particular location is called design response spectrum. Okay, this is the simplest way to understand the design response spectrum. There is a method to draw a design response spectrum, but we will not cover that in this video. Okay, let's talk about the design response spectrum in the IS code. And in IS code we can find this graph in which there is a plot of design acceleration coefficient, which is SA by G versus the natural period. Okay, and by using this curve we can carry out response spectrum analysis. Response spectrum coefficient is just spectral acceleration divided by acceleration due to gravity. We can easily find spectral acceleration by multiplying this coefficient that we can get by for a particular time period and multiplying it by 9.8. As we can see, this is for the 5% damping, and we can use this curve to design the structures that can resist earthquake. This much for this video, and thank you for watching.